This should always be part of our development lifecycle, where we're regularly testing for our code through static and dynamic analysis, and sometimes even penetration testing to evaluate the behavior of our code within the applications that we put out. What are some of the tools and that we can use for to ensure that our code is designed securely? We have static application security testing tools. These are tools that analyze the code for vulnerabilities. And then we have dynamic application vulnerability testing tools. These actually test the applications in real time once we have actually finished coding, and they actually help us identify the behavior of the application in a simulated real world environment. And then we can look at dependency checkers. One of the things that we see today is a heavy dependent on OSS components. We need tools that can analyze and monitor these third-party libraries and look for dependencies with known vulnerabilities to ensure that we can mitigate these vulnerabilities before they become a larger problem within our application. Let's talk about some best practices for secure coding. One of the first things that we can talk about is memory management and the use of memory safe languages. So for example, throughout the development lifecycle, we're selecting programming languages that are designed to handle memory safely and avoid the introduction of buffer overflows within our application and subsequently leading to vulnerabilities within the application. So for example, rather than choosing a language like C, which you need to actually ensure that you're managing memory safely, we can go with more newer languages that that have inbuilt functionality and capabilities to handle these safely. And then we can talk about input validation and sanitization. Anytime our application accepts user data, we need to validate and sanitize that data against what the application expects to ensure that we are not introducing vulnerabilities within the application, such as SQL injections and other command injection type vulnerabilities. We should avoid hard coding credentials and secrets within our applications. These include API keys and tokens and other secrets such as connection strings to data stores and other critical components of our applications that these can provide unwanted access to without the proper channels such as authentication and authorizing before having access to those. And then we can talk about the use of secure libraries and frameworks. A lot of our applications today are designed using libraries and frameworks that are out there. We can either customize these libraries and remove components and elements of it that our applications don't need to ensure that we are using these libraries safely.